In this video, I want to talk with you about joints and muscles as lever systems. Does it matter where a muscle attaches? And where a muscle attaches affects the speed of movement and the power of movement. Let's go through an attachment near the pivot point. So I want to compare two circumstances, a muscle A that attaches nearby and a muscle B that attaches at a distance. In both cases, the pivot is the same and the length is the same. We'll have both muscles contract by 10% of their length. So there's half, there's 25%, so 10% is about here. Here's half, 25%, 10% is about here. So if that's how much it contracts, then the muscles are going to change shape to contract to this amount. Okay, so that's the new position. The bone has to move that amount, and this bone has to move that amount. And let's say both muscles contract by 10% of their length in 1 second. Imagine that this is an arm, and so that distance is 20 centimeters. In other words, 20 centimeters per second for this hand. This hand has moved only 5 centimeters, therefore 5 centimeters per second. So if the muscles are exactly the same size and they each contract 10%, the muscle that's attached closer to the pivot point is going to move the hand out at the end a much further distance, 20 centimeters here, and the one that is attached much further out will have moved that hand only a small distance, which you can tell from just the amount I shortened it in the attachments here, 5 centimeters per second. So an attachment near a pivot point is faster, and farther from a pivot point is slower. So if I label these X and Y, muscle X and muscle Y, Y has more myosin heads per centimeter of movement. Y is slower, but it's devoting more myosin heads to each small amount of movement. That gives Y more power for lifting. So X is faster, Y is slower, but more lifting power. So you see close attachment points on animals that move fast. Runners tend to attach their muscles very close to the joints. And you see distant attachment points on animals that are specialized for power. This is very much like the muscle arrangement in a mole that uses biceps for digging. And this is a muscle arrangement in something like a deer that uses the biceps for running. The mole doesn't move very fast, but it gets a lot of power to push hard against dirt. The deer couldn't dig dirt very well with that foot, but it gets very fast speed for running.